Scientists have taken their first glimpse of a sample collected from the near-Earth asteroid Bennu and stumbled upon a good bit more than they expected. When they opened the canister containing the sample on September 26th, the researchers discovered an abundance of dark, fine-grained material on the inside of the container's lid and base surrounding the mechanism used to collect the extraterrestrial rocks and soil. In a groundbreaking revelation, NASA has unlocked the secrets of the universe by opening the largest asteroid sample ever collected. Inside, scientists found unexpected phenomena, reshaping our understanding of space and sparking global intrigue. That unexpected debris could reveal key insights about the asteroid before the primary sample is analyzed. The gumdrop-shaped capsule, released from the robotic spacecraft OSIRIS-REx, as the mothership passed within 67,000 miles or 107,826 kilometers of Earth hours earlier, touched down within a designated landing zone west of Salt Lake City on the U.S. military's vast Utah test and training range. According to a NASA blog post, the initial sample curation is going more slowly than expected, but for the most excellent of reasons. There's so much Bennu dust coating the inside of the canister and the outside of the sample collection head that disassembly is a little trickier than the team thought it would be. The very best problem to have is that there is so much material, it's taking longer than we expected to collect it, says Deputy OSIRIS-REx Curation Lead Christopher Sneed of NASA's Johnson Space Center. There's a lot of abundant material outside the tag SAM head that's interesting in its own right. It's really spectacular to have all that material there. Throughout Sunday morning, NASA tweeted historic updates from the sample's landing site in Utah. "We spotted the hashtag OSIRIS-REx capsule on the ground," they announced about 80 minutes ago. "The parachute has separated and the helicopters are arriving at the site. We're ready to recover that sample." UPI notes that the capsule reached temperatures up to 5,000 degrees Fahrenheit during re-entry, so protective masks and gloves are required to handle it, describing its payload as a 250-gram dust sample. 15 minutes later, NASA shared footage of the first persons to come into contact with this hardware since it was on the other side of the solar system. A recovery team approached the capsule to perform an environmental safety sweep, confirming there were no hazardous gas. "The impossible became possible," NASA Administrator Bill Nelson said in a statement. The Guardian reports he confirmed the capsule brought something extraordinary, the largest asteroid sample ever received on Earth. "It's going to help scientists investigate planet formation. It's going to improve our understanding of the asteroids that could possibly impact the Earth, and it will deepen our understanding of the origin of our solar system and its formation. This mission proves that NASA does big things, things that have inspired us, things that unite us." The mission continues with incredible science and analysis to come. But I want to thank you all for everybody that made the OSIRIS-REx mission possible. Professor Neil Bowles of the University of Oxford, one of the scientists who will study the sample, told The Guardian that he was excited to see the sample heading to the clean room at Johnson Space Center. So much new science to come. Before we move on, support us by hitting subscribe and the bell icon to get notified when we post new videos. Now let's get back to our topic. Johnson houses the world's largest collection of astromaterials from the solar system under one roof, including samples from asteroids, comets, Mars, the Moon, the Sun, and dust from other stars. Scientists use world-class laboratories to perform research on planetary materials and the space environment to investigate the origin and evolution of our solar system and beyond. From the beginning, the mission was a marathon. In 2004, a group of American scientists submitted an application for what would become OSIRIS-REx. But NASA returned the project with the lowest ranking, Category 4, or thanks but no thanks, Dr. Loretta said. The first proposal just bombed. The team tried again in 2007. This time, it scored a ranking of Category 1, but was too expensive to win funding. The third time was the charm. NASA selected the project in 2011. "So that began our real journey," said Harold Connolly, a cosmochemist at Rowan University who joined OSIRIS-REx 15 years ago. "The team spent another half-decade making sure all our little ducks were in a row," he said, including designing and building the spacecraft, mapping the trek to Bennu, and plotting the science campaign. OSIRIS-REx launched in 2016, embarking on a roundabout series of fuel-efficient loops before arriving at Bennu on December 3, 2018. Once the sample container is fully open in the coming days, the team will sort through the collected pebbles, using instruments built into the glove boxes to measure the rock's volume, shape, mass, and porosity. NASA will hold back 70% of the rocks for future scientists who might have better experimental tools. It will send between 4 and 5% of the haul to collaborators in Canada and Japan. The remaining 25% will be reserved for detailed analysis by the mission's science team, which consists of more than 200 people spread across 4 continents. "We are fully ready for the unexpected," says Daniel Glavin, an astrobiologist at NASA's Goddard Space Flight Center. Glavin leads the mission's 50-person organics team, which will explore the extent to which asteroid impacts set the stage for life. Whereas some have proposed that crucial organic molecules such as amino acids arose through chemical reactions at deep-sea vents, others have suggested asteroids could have seeded early Earth with them. So far, only 12 of the 20 amino acids necessary for life have been detected in meteorites, most of which are asteroid fragments. But Glavin and his colleagues have found that most extraction methods, which rely on warm water and mechanical stirring to dissolve the rock compounds within a meteorite tea, can actually destroy some of the amino acids. They've devised a gentler technique, using cool water and sound waves, and they are confident it can capture all 20. "We call it the cold brew," Glavin says. The team will use scanning electron microscopes, X-rays, and infrared instruments for the first examination of the material collected from Bennu. Together, the instruments will provide scientists with an understanding of the sample's chemical composition, detect any hydrated minerals or organic particles, and reveal any abundance of specific types of minerals present on the asteroid. "You've got really top-notch people and instruments and facilities that are going to be hitting these samples," Keller said. "The initial analysis will help researchers have a better idea of what to expect from the bulk sample collected from Bennu." As part of the preparation for getting it ready to travel, workers in a clean room removed the back shell of the heat shield that covered and protected the metal science canister full of extraterrestrial rocks. "All of the hardware appeared to be in good condition," says NASA's Eileen Stansbury, adding that it looked much like it did prior to launch before it traveled over 1 billion miles through space. While Japan previously brought back small amounts of dirt from a different asteroid, the new haul is the most extraterrestrial stuff brought home since the Apollo astronauts returned with moon rocks. NASA is currently working on another mission to return rocks from Mars, and Loretta is already dreaming of a sample return mission from a comet. But first, he's going to pore over the bits of an asteroid that he's devoted so much of his life to obtaining. "I have to be patient, and I'm really exercising patience," says Loretta, who notes that he couldn't just shake the returned capsule like a kid trying to figure out what was inside a wrapped Christmas present. "We've got a busy week ahead of us. The OSIRIS-REx mission may have come to an end, but the spacecraft remains fully operational in space. It will next visit Apophis, another near-Earth asteroid that was once seen as a major threat to crash into Earth. As humanity peers into the mysteries of the cosmos, NASA's discovery inside the largest asteroid sample unveils a new chapter in our cosmic understanding. Join us as we continue to explore the wonders of the universe, igniting curiosity and inspiring generations to come.